be reviewing our blood evidence stuff today. I want to walk you through like what you should have learned in the last 3 days. I know it's kind of crazy because like Thursday and Friday, you all were at home. And then yesterday we did that activity. So today is like day 1 of review, and I'm giving you like a study guide. Then Thursday will be a Kahoot and ask any questions that we have, go over anything that's still confusing. And then we have a small quiz on Friday. It's not supposed to be very tricky, and it's like 20 points. So nothing like super scary. But then next week we will be starting the blood spatter, and we actually get to let you all like touch a lab in person. What? It's like we don't even know what it exists, and you've done it kind of before. Maybe you're like, but it's fun. Like I like that one. Did you all do the different angles? And did you do motion though? You didn't do motion. I don't know how much motion we'll be able to do. But we need to at least do like a demo of it. I don't think we'll collect data because there probably won't be time. But like usually I make it like a 2 or 3 day lab, and we do like walking at different speeds and see like how the drops change. It's pretty fun. So, just not like your best shoes, or just bring grocery bags to put over your shoes. It's not that bad. Like you can keep yourself pretty clean. It's Halloween blood. Like it's not too bad. Okay, so to start our review, I'm gonna start with like the parts of blood and everything like we did, but we're just gonna kind of go rapid through everything we should know. And then I'm gonna give you time to work on your like study guide that I sent in the assignment today. So it shouldn't be super scary, but we shall see. All right, so this is our blood evidence review. I am going to record this, so if you need to like come back and watch it, I'm going to post this one. Most of our like live things, I'm recording one of my class periods so that people who are absent can get that information, or if you just like got really confused, you can go back and see it again. All right. So we were talking about the parts of blood. We know that we have the red blood cells, white blood cells, plasma, and the platelets. The red blood cells we've been spending a lot more time on than any of the other parts of the blood because they have those special proteins on the outside called agglutinogens. And they are cell surface proteins that we find on the red blood cells. So I have done some little like cartoon red blood cells that look like this. We said they looked like the old school like breath savers in real life because they have like the little dip in the middle. I was telling my first period about like the cream savers candy that was like they quit making it, thank goodness, because it's gross. But it was like berries and cream or like peaches and cream candies, and they were shaped like those breath saver mints. But my mom loved them, and like the smell was like nauseating. They were like so fake, fruity, sweet, gross. But that's the same shape, and these remind me of those more because those had color, like they were like purple and peach, and nasty. Okay, sorry for the distraction. So when we're looking at our red blood cells, we have these cell surface proteins, or some people don't have the cell surface proteins. We learned about 3 different proteins that we can find. We had the A proteins, B proteins, and then we added the extra step of the RH factor that can be found. So in this illustration, I'm just going to do the A's and B's, and then you would just like add the RH if you wanted to. So let's make this one have the A proteins, and this one can have B proteins, and this one gets A and B proteins, and then this one is going to not have any of those proteins on the outside. So these are your cell surface proteins. They're called agglutinogens, and they help your body recognize, is this my blood or is this like foreign invading and we must take care of this and destroy it? So if you don't have that agglutinogen, then your body will have the antibodies to it. So I'm putting antigen in quotations here because our body, if we say that doesn't belong to us, the cell surface proteins are recognized as antigens, which then your body says, okay, I have an antibody. It's going to bind to the antigen and it's going to mount an immune response and attack and try and get rid of this invading thing. So first, we got to look at our blood types. So if we have these blood cells that have different proteins on the outside, let's figure out which type of blood it would be. So if you have these A agglutinogens on here, what type would it be? It would be type A. Perfect. And then if we have the B agglutinogens, what would we call it? If you have those B proteins on there, it would be type B. There you go. And if you have both, what type do we call it? Yep, type AB. What do we call it when the cell is naked? Type O. There we go. So type O is going to be our protein, or like it has no proteins on the outside. We add the positive or negative based on if it has the Rh protein. If it does, we say it's a positive. And if it does not have the Rh protein sticking up, we say it is Rh negative. Okay, good. So let's think about what antibodies each of these types would have. So for type A, it would have the antibody to what? What would it freak out about? It would have problems if you found B. So it would have B antibodies. Type B would have what kind of antibodies? Yep. Type AB. This one's kind of tricky. Right. No antibodies to those agglutinogens because they have both. Their immune system will not freak out if they see A's or B's or naked blood cells around. So that's all good. Type O, though, what are they going to have an issue with? A's and B's. So we would have the antis for A and the antis for B. I'm getting lazy, is what's happening there with my writing. Awesome. Thank you, Cassidy, for writing those in. So these antibodies help your body recognize and react to the wrong blood type being there. Now, we first found out about this in a bad way, right? They tried to transfuse blood between species and it clotted up dramatically. We call that agglutination. So let's change the color here. So clumping is like clotting, but it's worse. So it's really, and it's from the agglutinogens. Agglutination is our big word. So this is not your platelets clotting, and those are what keep you from bleeding out. This is clotting due to the antigen antibody response. So when your body thinks that something doesn't belong there, it has recognized the antigen or the proteins on the outside of the cell, and it sends antibodies, and that is our immune response. When we have this happen for blood, the antigen antibody reaction for blood is agglutination. It causes the blood to clump up, and it ended up killing the animals that they tried to transfuse the blood with, because their blood would clot up and clog everything and they would be no more. So it's not something that you would want to repeat here. So what we're going to do is illustrate what agglutination looks like, and then explain how agglutination is what we were doing in our blood typing tests in those little plastic trays. So if we have a bunch of blood hanging out, right now, these blood cells that I'm drawing can move around freely, okay? Like they're loose, they're flowing in the plasma, happy. These blood cells are going to have, A or B? What do we want to do? I don't really care. A's, okay. So these are going to have A's as their cell surface proteins. They're agglutinogens. So if we have this blood and we give it to someone who's like a type O, so the scenario would be give A to an O blood type. The O blood type person is going to have antibodies. Antibodies are like little Y-shaped proteins. So this is antibody. And it's going to recognize those A's as bad. So it's going to bind to all of the A proteins. So it's kind of like a lock and key-ish. It's like a glove holding a baseball. You can pick your own analogy. It fits together, okay? And they bind, and now these antibodies cause these to stick together. So now these red blood cells can't flow around. They're stuck in a big clump with all these other red blood cells that are recognized as foreign and the antibodies that are stuck to them. So this makes a giant clump called agglutination that would be very bad if it was inside your body. But we can use this science of how the antigen antibodies work to do our blood typing test. So what we did was we have these little trays. So now we're moving on to blood typing. Let me label it. And these trays had 3 spots. And we put the blood in all 3 spots. So blood, blood, blood. Then we were going to add antiserums, which is the fancy word for the liquid that has the antibodies in it, to each of these. So what we did is we did anti-A serum into the spot labeled A. We put the antibodies to B into B. And then we did the anti-RH into the spot labeled RH. And what we looked for was clumping. So what I'm going to do for our test to keep things easier is, instead of having to look at like real pictures of blood on the Kahoot, we're going to use real pictures of blood because it's kind of fun to look at real pictures. On the test, you don't want to have any questions of like, is that clumped or not? Because that's stressful. So instead, what I'll do, if it is positive, like if there's clumping, I'm going to put a plus sign in the spot. If there's no clumping, I'm going to put a minus. So then all you have to do is say, if there's clumping, that protein is there. So clumping means positive for that protein, or agglutinogen. It means we saw agglutination. So this one, it has clumping in A, it has clumping in RH, but it does not have clumping in B. What would be that blood type? A positive. So Cassidy told me on here, A positive. So clumping in A means the A protein was there. No clumping in B means there was not any B protein. Okay, those antibodies did not find anything to stick to. The RH, it clumped, which means the RH antibodies found RH proteins and made the blood clump up. So let's look at a few more practice ones. And I won't color the blood in it, so it'll be easier to see. Okay, so let's say I'm getting pretty good at writing without looking at what I'm writing. Like, it's weird, but we got the new iPads, so hopefully I'll be able to make like fancier note stuff for you now. We'll see. Okay, so I'm gonna change this to red. Let's say on the first one, there was no clumping in A, there is clumping in B, and there's no clumping in the RH. And then on this one, let's say no clumping in A, no clumping in B, no clumping in RH. And then this one, let's say it clumped in A, it clumped in B, it did not in the RH. So look at those three and let's figure out those blood types. So what do we think this first one is? This is 1, 2, 3. So what type of blood would I say this person had? Okay, so it has the B protein, so I'm going to write that letter, and it does not have RH, so you're right. It is B negative. So then what about this one? It does not have any A, it does not have any B, and it does not have RH. O, yes, this is O negative. So if you don't have any of these A or B, that means it's type O. And then you look at the RH, and if it's negative, you write negative. So then what about this one? We do have A, we do have B, but no RH. There you go, AB positive. So it clumped up for A, which means it had the A proteins, like the A's stuck to the antibodies and clumped, the B's stuck to the antibodies and clumped, but the RHs did not. So this is actually negative. Is that what you're humming me? I wrote it wrong. Exactly. Yep. So you look at the A and B to figure out that type, then you add the plus or minus from the RH. I'm sorry for miswriting that. So it's AB negative for that one. Yes, these are the blood typing plates. Okay, so the other thing that we have been studying is the presumptive test for blood. So we learned about the Kastle-Meyer test. And this was the one on CSI where they swab it, they add the drops, and it turns pink. And we saw that that's what it really did. We like this test because it's really cheap. It's cheap, it's quick, and it allows us to not look like dummies by sending samples off that are not actually blood, which would be a waste of time and money. So we are going to need you to know the different chemicals that we studied. So like I said it like every time I added the drops, remember yesterday? And then we filled in that table on our assignments. Like that would be a good place to look. So we had water that we added to the Q-tip so that we could transfer the stain onto the cotton swab. Then we had the ethyl alcohol. So just the kind of alcohol that's in hand sanitizer. It cleaned the sample and it exposes the hemoglobin so that it is a very sensitive test. It can detect the 1 in 10,000, right? So 1 drop of blood and 10,000 drops of water, this test would still react. Then we added the really scary looking word, the phenolphthalein, which was an indicator that will turn pink if the next step reacts. And so this is where people would get a little stumped because hydrogen peroxide is actually what is causing the blood to react, right? We add it, it's releasing oxygen. The thing that is changing colors is the phenolphthalein. So it's not supposed to do anything. It's just sitting there waiting on a reaction to happen. So the color change should not happen until after you add that hydrogen peroxide. So then we talked about luminol. We said luminol has some drawbacks because it dilutes down the blood so that it would not be good for DNA testing, which is pretty important if we're trying to match a sample to a suspect. But if we don't have any other options, it is very good to help us see where blood has been. It can react with some other things, so we have to make sure we're aware of that. Like it can react with copper and like bleach sometimes will light up too. When we looked at this demonstration, it only glowed for like a few seconds. And that's because we were using simulated hemoglobin. So we were actually using like a copper compound. And it reacted and then it was used up really, really fast. When this is sprayed on blood, remember there's 1 billion red blood cells in 2 to 3 drops. Each red blood cell has 4 hemoglobin proteins in it. So you have 4 billion hemoglobins to react with the luminol in 2 to 3 drops of blood. So it's going to glow for a much longer time than our demonstration. So you'd have enough time to photograph the scene. But it still is temporary. Eventually it will stop glowing. So the reason it was glowing is it's going to react with that luminol, or the luminol reacts with the hemoglobin. Again, this is like an oxidation reaction. This time, we saw in that packet that luminol is made of carbon, hydrogen, nitrogen, and oxygen. The nitrogen is going to switch spots with oxygen in the blood, and it's going to release energy in the form of light. So the light is given off when those swap places. So as long as luminol is finding hemoglobin to switch places, it's going to keep glowing. Once the reaction is done, then the glowing is going to stop. And so this is a chemical reaction, very similar to what happens in the fireflies or lightning bugs, whatever you call it in your family. Very, very similar there. Okay, so on our assignment today, there's some terms that I want you to find the definition to. I mean, just Google them. That's really the point there. Then you have some questions that you can find the answers in our notes from Thursday or in the PDFs from Friday and yesterday, unless you just remember it off the top of your head or you got it from our little discussion right now. So you're going to fill in that Google Doc. You're going to turn it in for your assignment credit today. Tomorrow is going to be our first day of the new round of Genius Hour. So make sure you complete that assignment on Canvas. And then Thursday, we're going to Kahoot and go over anything that might still be confusing you before our quiz on Friday. All right.